Hey everyone, let's go over how to do the project. Open up Minitab and just follow the directions. Now, just to be clear, I'm going to start from the beginning. And we're going to go until they're through the end of this right here, okay? I'm going to let you handle the simulation of 1,000 rolls of 2 dice, okay? So let's buzz through this, right? So here, we just label our stuff. Y, and please, please, please save your stuff. I'm not going to save this, but you should save it, right? Okay, so you enter in the values of the die, right? Right, and see, I'm just following the directions. Now, the reason for the whole 0.166667, right, this is an approximation for 1/6, right? I hope we all know that there's a 1/6 chance. I don't know why that's weird. Okay, right, there we go. Right, there's a 1/6 chance of getting any one roll on the die, so they're just approximating 1/6. So I hope we all know that, right? That's what a fair die is, a fair 6-sided die, right? We go here, right, and we call it roll Y. Again, I'm just following the directions right here, right? Label it roll Y. Okay, we're going to simulate 1,000 die rolls, calc, random data, number of rows, 1,000, storing columns, roll Y, select, distribution, please change that to discrete, values in, yep, it's going to be Y, probabilities in, yep, that's going to be P of Y, okay. All right, so there are 1,000 rolls, great. Now we're going to go to stat, tables, tally, include the percents there, but for the variables, we're going to do roll Y. All right, now my data right here is probably going to be a little different from yours, but that's fine because our random, 1,000 random rolls are going to be a little bit different, but they'll be similar, right? Okay, so now we do calc, column, statistics, mean, the input variable, we want it to be the roll Y, right? He doesn't explicitly say that, but that's what we want because that's the mean we're finding. 3.441, right? Should be 3.5 in general, so pretty close. Do the same thing, except now we do the standard deviation. And then you do need to do this manually, right? So we get 1.717, square it, 2.948. So remember that, okay? 2.948. I'm just going to go to here. I guess we'll call this variance for Y, or for roll Y. 2.948 was that? Oh, I see, I already forget. I think that's what it was, right? You can just create or whatever. You can put the date if you want, right? 1.717. 2.948. Yep. Okay, we're good to go. Okay, great. So anyway, to get back to that file description worksheet, it's right there. Okay. Get it right there. All right. Now, we go to here. And you just do it again, right? Roll Z. Gonna roll it 1,000 more times, right? Count. Random data, right? You'll be able to do it at this point. Change the Y to a Z. Make sure to keep those little apostrophes. But anyway, we get more rolls. Again, we go to stat, tables, tally. Again, change that Y to a Z. You should be good. Note that our numbers are a little bit different, right? And you'll see this when you calculate column statistics, mean, and again we're changing this to Z. Calc, column stats, standard deviation, roll Z. Right, again, a little bit different, right? Mean is 3.54. Right here, it's a little bit bigger than average. Before, it was a little bit less, right? Standard deviation, not quite the same. Similar, not quite the same. Again, we're going to square this. 1.660. squared, 2.756. So again, I'll just add that to the description here. 2.756. All right, there we go. Now the question is, why are they asking for the variance, not the standard deviation? All right, seems that variance is interesting. Anyway, here, this confused some people in class. All this is saying is just make a chart of all the sums that you can get from rolling 2 dice, right? And then when you do that, you don't actually have to do this as far as I'm concerned. But here's how it's going to be useful. Right, so we get that right there. Now x, all we're doing here, the same way that for y, we had all the possible rolls for a single die, right, 1 through 6, we're going to have all the possible sums from rolling 2 dice. Well, that's just going to be 2 through 12, right? Well, sometimes Minitab Online is a little fussy when it comes to typing stuff. I'm not totally sure why. Right, so 2 through 12. Again, I hope that that's clear, right? You roll 2 dice, add up the entries, and that's what you get, 2 through 12, right? If it were 3 dice, it would be 3 through 18, right? Now, here's the question. What's the frequency, right? What's the number of ways that you can roll 2 dice and get a 2? Well, there's only 1, right? Rolling 1 and a 1. How about 3? Well, there are 2 ways. You could roll 1 and a 2 or 2 and a 1. Those are different, right? Because we label the dice. Right, if you think about it, this pattern continues up through 7, and then it actually starts to descend. Whoop. And of course, there's only one way to roll a 12, right? Double 6s, right? So don't just copy this stuff down, right? Make sure you understand what you're doing. All right, now, anyway, for the probabilities, same thing that we did before, maybe a little bit more involved, I guess. So calculator, store in the variable p of x. Yeah, actually, no, I guess this is a little different because before we just entered 0.1666667, right? Here we're actually going to calculate the probabilities. It's a little more involved. Right, so anyway, we do... Now, be careful with the expression, right? So I recommend selecting it. And then dividing it by, and then type sum, parenthesis, select it again, and enter. And there you have the probabilities, right? And this should make sense, right? This probability right here on top, that's 1 divided by 36, which is the probability of rolling a 2. 2 divided by 36, probability of rolling a 3, right, etc. Okay? Now, for x times the probability of x, right, we do the same sort of thing, right? Calculator, store the results in, just be a little careful here. Let's choose, we choose this guy. Okay? And then, let's get rid of all this. We're going to do x times, and then unselect this guy, and then select that guy. Whoop, p of x. I think that should give it to us. Right? There we go. So that's the expected value for that's each component of the expected value. And then we do column statistics, and we actually find the sum. And then there's actually a little typo here. It says input variable y, p of y. That doesn't make any sense. It should be x, p of x. And so we get 7, right? And that is the expected value of a die roll. It's 7, the average die roll, right? 7. And at that point, I'm going to stop right here, leave you to do the rest. Remember, this show and theory part is cool, but a little bit beyond the scope of what we're doing. So if you do that, you'll get extra credit. And remember, please save your document.